Hello everyone, welcome to the beginning of Unit 3. Today we're going to talk about something called the chain rule. And so what we're going to work on today is identifying composite functions and then applying the chain rule. And so this chain rule happens if you have a composite function. And a composite function, if you don't remember, is basically when you have one function inside another function. So let's just look at the definition here. This said is if f is a differential function at the point u equals g of x and g is differentiable at x, then the composite function f of g of x is differentiable at x, and the derivative of f of g of x is f prime of g of x times g prime of x. And so that is a lot, and it might seem really confusing, but what it's essentially saying is that the derivative of a composite function is the derivative of the outside with the inside plugged in times the derivative of the inside. And so every time we do one of these problems, you need to determine what is the inside function and what is the outside function. And then we'll go from there and we'll put all of it together. Just like in normal calculus, there's just more than one way that you can use this notation. And so this is like one type of notation that we're going to use today. There are also other kinds of notation, and we'll work on that later this week. And so this one says find the derivative. And so this is a composite function, and it might not look like one from the outside, but there's two functions here. There's this inside function x cubed plus 5x, and then there's the outside function, which is essentially x to the fourth power. And so because of that, you need to use a composite. You need to use the chain rule because it's a composite function. The only reason that you would maybe not use the chain rule is if you could get it to not be a composite function. But the only way that you could do that is if you did x cubed plus 5x to the fourth power, and that just would like take way too long. And so what I'm going to do here is I'm going to identify my inside and outside function. And so my outside function, I'm going to use f of x to represent. You technically don't have to use like these letters. You could use anything as long as you're using the chain rule. But again, I'm going to write the chain rule up here so that we can keep that, we can remember it. And so I'm just going to write my information out to the side. Eventually, maybe you'll be able to do some of this stuff in your head. But my outside function is x to the fourth power. I'm basically just thinking about, like, I'm just kind of covering up the inside part, and then I'm thinking about it as, like, blank to the fourth power. So x to the fourth power. The derivative of that, if you look at the chain rule, we see right over here that we do need the derivative of f. So I'm going to write the derivative of f, and that is 4x cubed. And then my inside function is going to be, and I'm going to highlight like what I've labeled. So this is that part. This is important. And then this whole part is going to be my inside function stuff. So my inside function is x cubed plus 5x, and then the derivative of my inside is 3x squared plus 5. So that is basically like all the heavy lifting we have to do. We found all of the derivatives. Now we need to put all of that information together. And so what this is saying here is it's saying the derivative with the inside plugged in. And so every place I see an x, I am going to replace that with g of x. And so the derivative of f is 4x cubed. So I'm going to write 4 blank cubed. And then instead of putting an x in there, what this notation is saying is put a g in there instead. And so I'm going to say x cubed plus 5x. And so essentially, it's like kind of the exact same thing as we had before. I'm just moving that 4 out in front and reducing this by 3. And so it really does just look like the power rule. The only difference is I'm going to multiply by the derivative of the inside. So because the inside is x cubed plus 5x, I'm going to multiply this whole thing by its derivative, which is 3x squared plus 5. And that is my answer. So that is the derivative of x cubed plus 5x to the fourth power. So let's go on. This next one, I'm again going to write the derivative, the chain rule out here. You guys are welcome to try this one on your own because it's kind of the same. It's very similar to the last one. So I'm first going to identify my outside function, and that is going to be x to the fifth power. It's pretty easy to determine the outside function. It's just the one that doesn't have something inside of it, or the one that has something inside of it. And then the derivative of that is 5x to the fourth power. Then my inside function is x squared plus 6x, and then the derivative of x squared plus 6x is 2x plus 6. And now I'm going to put everything into my chain rule formula. So what's going to stay outside is my derivative of f, and that's 5x to the 4th power. And then I am plugging in g of x, which is going to look exactly like this looks over here. So I'm plugging in my original g of x, and then I am multiplying by the derivative of the inside, which is 2x plus 6. And we don't need to clean that up. We can just leave it exactly like this. Just make sure that you have the derivative of the inside function in parentheses, because if not, you're going to think that you're just multiplying this part by 2x and then adding 6, but that's not what's happening. You're multiplying this whole thing by 2x plus 6. And so that's just an order of operation thing. So if you don't have those parentheses there, you're not communicating the right idea. So that was the chain rule when we just kind of had some polynomial functions. Now we're going to have a little bit of a trickier function. So this says find the derivative of h of x. So again, I'm just going to write out the derivative just because you can never, or I'm just going to write out the chain rule formula because you can never forget this. You can never write it too many times. And I'm going to start by identifying the inside and outside function again. So the inside function, the outside function is going to be the square root of x because sine of x is inside the square root. Okay, so that's that. And then remember, the square root of x is equivalent to x to the 1/2 power. And so if I want to find the derivative of that, I'm going to set it up to find the derivative, which means putting it in exponential form. And then I'm going to take that derivative. And honestly, you guys might just be getting to the point where you're memorizing this. And so I'm actually going, for the sake of like this problem looking nicer, I'm going to simplify this. And so this is what the simplified problem would be. Then the inside function is sine of x, and the derivative of sine of x is cosine of x. And so now I'm going to go over here and put everything together. So it'll be the outside function. I'm just going to leave a blank there for a second, and then I'm going to put the original inside function back in. But obviously it looks like a little different because the derivative has been taken, and then I'm going to multiply all of this by the derivative of the outside, and then I'll just clean this up because it really doesn't take that long. And this is our answer. Just like that, not too bad. Okay, let's see how many. We have a couple more examples. This one is weird because you might notice that you have a quotient and you have a composite function. So the quotient is 1 over this whole 1 over 2x plus e to the x power to the 3rd power. And then we have over here, we have a composite function. We have an inside function and then an outside function. And so, yes, you could use the quotient rule here too, but that really would just be kind of time consuming. And so one thing you can do here is because the numerator is a single term and it's 1, so that makes everything easier. I can rewrite this just the way that I can bring like x to the top by making this x to the -1 power. I can move this whole expression to the top if I just change this exponent right here. So I'm going to make this 2x plus e to the x power to the -3 power. And that is equivalent to this. And the reason it looks so simple is because there's a 1 on top. So basically it's like 1 times 2x plus x to the -3 power. And because of that, I now no longer have to use the quotient rule. I'm just going to use the chain rule. And so again, I will write my chain rule over here. And then I will identify some parts. So inside, or I guess it doesn't really matter which one I write down, but the outside function is going to be x to the -3 power. Its derivative is -3 x to the -4th power. And then for the sake of this looking cleaner, I'm going to clean that up, simplify it. And then the inside function is 2x plus e to the x. The derivative of 2x is 2, and the derivative of e to the x is e to the x. And now I will just plug everything in. So the derivative of the outside is -3 over blank to the 4th power, because I'm not going to plug an x there. It's asking for me to plug g into x. And then I'm just going to put 2x plus e to the x power. And that's to the 4th power. Sorry, my 4 looks kind of big. Oh, it went back. I don't want that. Okay, here we go. And then I'm going to multiply all of that by the derivative of my inside function, which is 2 plus e to the x power. And that is our answer. And I'll simplify it so it looks nicer. But just make sure that when you do the derivative of the outside, you keep it in parentheses if it needs to be in parentheses. and that is the derivative. Okay, we got two more. So this one looks different, right? Because it's not like telling you what your equation is right away. It's saying let f of x equal the natural log of x and g of x equals 3x to the fourth power plus x minus 5. If f of x equals f of g of x, find h prime of x. And so the reason I put this on here is because this is a common question to ask, is to use just this notation right here and ask to find h prime of x. And you need to recognize that this notation right here is a composite function. And so if I'm going to find the derivative of h of x, I got to use the chain rule. And so I know already that h prime of x is going to be equal to f prime of g of x times g prime of x. And so I can just go ahead and kind of do the same thing that I have been doing. There's not really like a need to find the regular h of x. If I were to find the regular h of x, though, all I would do is do the natural log of 3x to the fourth power plus x minus 5. Like, that is what h of x is. I know that because I know that the outside function is the natural log, and then this is the inside function right here. But you really wouldn't even need to know that in order to solve this problem. But I'm just going to keep going. So the outside function is the natural log of x. The derivative of the natural log is 1 over x. The inside function is 3x to the fourth power plus x minus 5. Its derivative is 12x cubed plus 1. So all of the hard work has been done now. Now I just need to plug things into my chain rule equation. So outside function is 1 over x, but in x's place, we're using function notation, and we're placing 3x to the fourth power plus x minus 5. And then I'm timesing by its derivative, which is 12x cubed plus 1. And then I'm going to simplify. And that's our answer. One more problem, and then this one is you have a table. And so again, these are common problems. It's really there to make sure that you actually like recognize the chain rule. And so the following table gives selected values for the function f and g and their first derivatives. Use these values to commute each indicated value. Quantities. So number 1 says g of f of 1. Now, maybe I want you to try this. Take like 30 seconds and try it. I'm going to keep talking, but I would like you to try. So for this one, if you tried it, there should be no derivative involved because there is nothing in this problem that tells you to find the derivative. It says find g of f of 1. So everything is the original function, so you do not need to use anything crazy here. And so to do this problem, you will find f of 1, and f of 1 is 3. And then you will find g of 3, and that is 4. Oh, wait, sorry. And then you'll find g of 3, and that is 6. And so that's your answer for this one. So really, it might look like it is a trick question, but it is not a trick question. And so I'm putting that on here because we're so used to doing calculus that sometimes we get in routines and we kind of start memorizing procedures rather than concepts. And so then sometimes we do calculus when we don't need to do calculus, and we do algebra when we need to do calculus. And so we just have to be in the mindset of looking at a problem and recognizing what do we need to do first. So try to do the next one. The next one, notice that there is no calculus in there, so don't let it trick you. But I'm just going to first find f of 4, because that's how you do these problems. F of 4 is 3, and then f of 3 is 4, and that is your answer for that one. So now we have one more problem, and this one actually just follow what it's doing. You don't have to do anything tricky. You might think that you need to use like something new and some calculus, but you really don't have to. So you're just going to start by finding g of 1, and g of 1 is 5, and now you're just going to find f prime of 5. F prime of 5 is -2. So there really wasn't anything crazy you had to do for this one. That's all you had to do. And so that's it. That's just like kind of you using the quotient rule, whether you really know it or not. So that's it. Thank you for watching this video. Goodbye.